We're applying two particular rules and we're going to be doing some integration of some straightforward functions here. The two rules that we're applying in this video to demonstrate the use are listed. First one listed there is when we have the integral of some constant a, so a is a constant or a real number, as opposed to a function. It's not a function, it's just some real number. So when we have a constant times a function and we integrate that, you can see we can displace or reorganize the constant out the front of the integral sign, and the integral of a times f of x dx equals a times the integral of f of x. Now that can be handy. Okay, it's very handy sometimes. Okay, might be for this subject, or if you do a more specialized mathematics too, like what was called Math C or specialist mathematics, something like that. But that's definitely one to always be prepared to use. It can be very handy at times. The second rule, which we'll demonstrate, is the integral of the sum or difference of two functions, which is shown there, is the integral of the first function plus the integral of the second function if it's a sum, or it's the integral of the first function minus the integral of the second function done separately. Also handy, ditto. So let's look at those. We have an example here where the given f of x is 5 over x squared plus 1. So if we have to integrate that with regards to x, we'd have the integral, the indefinite integral of 5 over x squared plus 1 dx demonstrating both rules plus use of our index laws. What we could do if we want to is 5 times the integral of x to the negative 2 dx. So just putting the first term in accordance with the first rule, putting the a at the front, also using our index laws, where 1 over x squared equals x to the negative 2. And we're also applying the second rule as well, because as you can see, I'm going to take the integral of 1 dx. And then it's just a matter of using our previously learned rules. And so we have 5 times x to the negative 1 over negative 1. And there will be a plus c, but you're going to see what I do in a second with that. Integral of 1 is x. Okay, now what we have here, there'll be a constant from each of these integrals here, an arbitrary constant. So we'll just put it together. It's going to be a constant anyway, so two constants make a constant. So I'm not going to get too pedantic about constant 1 and constant 2 makes constant 3. You could do that if you want to, not really needed. So tidying up now, we have negative 5, and putting it back in the form that it was given, in a more of a reciprocal form. So negative 5 on x plus c, or if you prefer, if you like your leading term to be positive, it'd be x minus 5 over x plus c. Okay, so we have an indefinite integral here, and likewise we can use similar tactics there. So using that second rule, we have the integral of x to the negative 2, and applying our index laws as well, which facilitates this work, dx plus the integral of, now we could put the 2 out the front, 2 times 1 over x cubed, which is 2 times x to the negative 3. So we'll take the integral of that, dx. So applying the integration now, we have x to the negative 1 over negative 1. There will be a plus c. We have x to the negative 2 over negative 2, and there's also a 2 times that. Now when you multiply a fraction by 2, it basically only affects the numerator, so if you like you can pop him up there on the numerator and we have a plus c. Tidying it up now, we have negative x to the negative 1. The 2's cancel out as such, and we have minus 1 over x squared plus c. And I'm taking this one really slowly, so you might not have needed these last 2 lines. You could have condensed it into one perhaps. Whoops, that's not what I meant to do. That's better, that's what I meant to do. And 1 over x squared plus c. So we have negative 1 on x minus 1 over x squared plus c. So be prepared to use these 2 very handy rules for integrating functions.